So this lesson is on complex arithmetic series. So these are problems where the problem ultimately reduces down to some arithmetic series, but it may not exactly be a straightforward series. So here's an example of a problem. We have 2005 plus 2004 minus 2003 minus 2002, etc., all the way to plus 5 plus 4 minus 3 minus 2 plus 1. And we want to figure out the sum. So the first thing we want to do is really identify what the pattern is, because we have some pluses and some minuses. So it turns out that we have two pluses, then two minuses, then two pluses, then two minuses, then two pluses, then two minuses. So the pattern is two pluses and then two minuses, repeating indefinitely until you get to the end. All right. So now we want to group it into an intuitive form because there's a lot of repetition here. And the reason we want to group it is because there seems to be a way that the pluses and minuses can cancel. And indeed there is. So we want to group it into four terms because the series repeats every four terms, right? You have two pluses, two minuses, so that repeats every four terms. So if we group it into four, we have all the way to the end is 5 plus 4 minus 3 minus 2, and the 1 is kind of left on itself. And the reason we know that the 1 is left on itself is because the minus 3 and minus 2 are both minuses, and we started with 2. The end of this is 2 minuses, so that means this is by itself. All right, now the next step is calculating what this is. So it turns out that each one of these parentheses actually has the same sum. So 2005 plus 2004 minus 2003 minus 2002, well, that's just 2005 plus 2004 minus, I'm going to write this out vertically, minus 2003 minus 2002. Well, this is just equal to 2 plus 2, which is equal to 4. So this is 4, and this is 4, and this is 4, and this is 4. So these are all 4s. And then you have a 1 right here. So the question is, how many 4s are there? Well, how do we figure this out? Well, one thing we could do is we could look at the first terms of these series, right? We have a 5, 2001, 2005, 1997, right? So we have a series that's like 2005, 2001, 1997, all the way to 5. And once we figure out how many of these first terms there are, then we could just multiply that by number of 4s by 4, and that will give you the sum. And then we add 1, and then that's the answer. So number of first terms is just 2005. Here the common difference is 4, right? So, or actually minus 4, but it's 2005 minus 5 divided by minus 4 plus 1. And the answer to this is equal to 500 plus 1, which is 501. So there's a total of 501 of these little groups. So that means the final answer is 501 times 4 plus 1 is equal to 2005. So what we did here in summary is we first figured out what the pattern is, and based on that pattern, grouped them so that they're easier to calculate. Turns out that every single one of these nasty expressions is just 4 itself. Once we grouped it, we need to figure out how many 4s there are in total. And to do that, we used these arithmetic sequences, right? So we just took the first terms and calculated how many first terms there are. We calculated there's 501 first terms, so we did 501 times 4, and then we added 1 because there's an extra laggard 1 right here to get the final result of 2005.